Well, hello. This is Miss Cronin coming at you. This is my first video from the 2021 school year. We're going to be talking about polynomial end behavior. And for our pre-calculus class, this corresponds with lesson 2.2 in your textbook. You guys, right now, if you have not already done so, pause the video and go to the Canvas page and print out this 2.2 practice. This is the assignment that's going to go with the lesson. And this is expected to be done by this Friday. So, and also when you go to Canvas, submissions that you make on Canvas has been altered slightly. There's a video there that you should watch so that you know how to submit assignments most efficiently. Okay, so what we're going to look at here in this lesson is the end behavior of a polynomial. And the end behavior is based on two things. Oops, I have these backwards. Hold on. So you may want to pause the video right now and copy down this chart and then follow along as we go here. So we're looking at polynomials, which we've studied extensively. Polynomials, you have linear functions, y equals mx plus b is a polynomial. Quadratic functions, when you have x squared, is a polynomial. Polynomials have whole number exponents on the variable and real number coefficients. So there's two things that are going to make a difference on the end behavior of a polynomial, and that has to do with whether the degree of the polynomial, which is the degree of the term with the highest power, the degree, if it's even, then that's going to impact the graph in a certain way, and if it's odd, it impacts it differently. And then also the lead coefficient, whether it is positive or negative. So if you have a polynomial whose degree is even, so we're going to go across this column or this row with even, with an even degree, but with a positive lead coefficient, the ends of the graph are both going to go up towards positive infinity as x gets really close, as x gets bigger and bigger towards positive infinity, or when x gets smaller and smaller towards negative infinity. Both ends of the graph are going to head up to positive infinity. And I also want you guys to be writing this in limit notation. So to review limit notation, you write LIM for limit of f of x. If this is function f of x, you name it whatever the function's name is. That's what you would put there. If it was g of x, you put g of x instead. If it's an even degree polynomial, the ends of the graph are both going to either go up to positive infinity, both ends will go to positive infinity, or both ends will go to negative infinity. So you can, when it's an even degree, you can write it as a single, you can use a single limit notation here, because it's going the same whether it's going to, as x goes to plus or minus infinity, both ends of the graph are going up, which means they're going towards positive infinity. So the end behavior of all of the polynomials is either going to be infinity or negative infinity. So when you're writing out the limit notation, you tell me what, as x goes out this way, as x goes to positive infinity, what's happening to y? Well, in this case, it's going up to positive infinity, and as x goes the other direction towards negative infinity, it's still going to positive infinity. So now the next one here is if it's an even degree, but with a negative lead coefficient, both ends of the graph are going to go down towards negative infinity. And to write that in limit notation, you can write the limit of f of x, or whatever the function's name is, as x approaches both positive and negative infinity. And since they're both going down, they're going towards negative infinity. So even degree polynomials, both ends go up or both ends go down. If it's an odd degree, what's going to happen with the ends of the graph is going to depend. They're going to go with odd degree, the ends go in opposite directions. So even degree, they go in the same direction. Odd, opposite. And odd kind of looks like opposite. So that can help jog your memory, hopefully. But if the lead coefficient is a positive value, the ends of the graph are going to go off like that. And what's happening in the middle, the reason I'm not connecting this is because they're going to look different when you're in the middle of the graph, depending on what the degree is and how many terms there are and lots of different things like that. So we're just looking at what's happening to the very end as x goes to positive infinity or negative infinity. So in this case, when it's odd, you're going to need to write two limits, because we're going to look at what happens as x goes to negative infinity. And if you look, if it's an odd degree and a positive lead coefficient, the ends of the graph are going down to negative infinity. And on this side, the limit of f of x, as x is going in the positive direction, well, the y values are going up to positive infinity, so it looks like that. And then the last situation here is if you have an odd degree and we have a negative lead coefficient, the ends of the graph are going to look like that. So writing it out in limit notation, as x approaches negative infinity, f of x is going up to positive infinity. And on the other side, as x is getting bigger in the positive direction, so as x goes to positive infinity, your y values are going down to negative infinity. All right, so you're going to put all that together. If you need to fill this out, just click pause and then come back. We're going to put all of this together to do this worksheet, and it's pretty short, but you're going to look at, for number 1, you have A, B, and C, and their graphs, and you're going to tell me what you know about the degree and what you know about the lead coefficient based on what's happening with the ends of the graph. So for part A, 1A, the ends are both going up. So think about what that means. Is the degree even or odd? And write it down. And is the lead coefficient positive or negative? So going back to the chart, both ends are going up when it's an even degree and a positive lead coefficient. So use that chart to answer these questions. And in particular, this looks like a parabola. So it's probably degree 2, because you can have up to, if the degree is n, you can have up to n minus 1 twists and turns in the graph, or extrema, which means maximums or minimums. But that's not, you don't need to be so specific. I'm just looking, when you're telling me the degree, is it even or odd? And in this case, because the ends go off in the same direction, it'd be even. And the lead coefficient, because the ends are going up, that lead coefficient would be positive. So you're just going to tell me whether the degree is even or odd, and whether the lead coefficient is positive or negative. Then do the same thing for B and C. Okay, number 2, you're going to sketch a graph with the given characteristics. So the degree should be odd, and which means the ends are going to do what? Hopefully you're saying opposite directions. And the lead coefficient is negative. So you can go back to that chart and you're going to look at what the ends are doing, but you're going to actually graph, I want you to actually graph a function. So you're going to connect a polynomial function, so you're going to connect, make connections with the ends of the graph. So like, it'll look like a continuous function like you see in A, B, and C. And then in number 3, you have A, B, C, and D. You're given an equation, and without using a graphing calculator, I want you to tell me what the ends of the graph are going to do. And it may be helpful to actually like draw it out before you actually write out the limit notation. But if you look at this function right here for A, f of x, the degree is 4, which means the degree is even. The lead coefficient is -3, so even degree. The lead coefficient is negative, so I'm going to abbreviate that, which means the ends of the graph will go, because it's even, they're going to go in the same direction, and because it's a negative leading coefficient, they're both going to go down. So writing out your limit notation, again, with an even degree, you can write it as a single limit. You can split it into two different ones. I'll do that just because so you show you how to do that. As x goes to infinity, f of x is going towards, it's going down, so it's going to negative infinity. And then on the other side, as x goes to negative infinity, the y values, f of x, are going towards negative infinity as well. So this up here is just to remind you how to write in limit notation. So do that for b through d. Look at the degree, look at the coefficient, and then determine the limit, the end behavior, and write it in limit notation. So that is 2.2, and it's a very important concept. If you're doing this in Algebra 2, which is where you first are introduced to this, it's less than 3.7. So if you are, so I'm going to have the same video for Algebra 2, so if that's the case, then we're talking about less than 3.7. So get this done and turned in. And notice that the name of the function changes. So instead of f of x, you would write g of x when you're writing that limit notation. And then bring your questions to class and submit the assignment if you don't have any questions. All right, see you.